Hello and welcome to lecture number 11. We are continuing with the concurrent assertion operators. In the last lecture, we saw the clock delay and clock delay range operators. And now this lecture will see consecutive repetition operator. Consecutive repetition operator star M. Star is the syntax. And M means that the signal, in this case signal B, must be true on M consecutive clocks, just like the name implies. So in this property, we are saying that at passage of clock, if Z is high, starting next clock, because this is an non-overlapping operator, SC1 should hold. SC1 says that A being true, one clock later, B should remain true for two consecutive clocks. That relationship is shown here. And it must be true on consecutive clocks. M can be greater than or equal to 0. When M is 0, it's called an empty match. And we'll see that a bit later. M can not be infinite. You do not want to, it makes actually no sense to see if signal remains high with this particular consecutive repetition operator, that it remains high forever. You could simply say A pound 1 B, and there are other ways you can 1 colon infinity, for example, and that's another way you can achieve that particular spec. But in the case of consecutive, it doesn't make sense to have this 2 to be infinite. So here is a clear definition of what this means is equivalent to A pound 1 B pound 1 B. This is identical to A pound 1 B star 2. Here's a simple simulation log. Z is true at this clock, A is true at the next clock as required by non-overlapping operator, and B remains true for two consecutive clocks, and the property passes. In this case, Z is true, next clock A is true, but B does not remain asserted for two consecutive clocks, and the property fails. Very intuitive. That's a consecutive repetition operator. And just want to make sure that we understand, and which is quite intuitive actually, that since we are looking for B to remain asserted for two clocks, then the overall repetition sequence matches at the end of the last iterative match, which makes sense because we are trying to make sure that a particular given signal remains asserted or deasserted for m number of clocks consecutively. Okay, so let's look at the consecutive repetition range operator. What this sequence says that if Z is true at passage of clock, SA1 should hold, and SA1 says that A being true, one clock later, B should be true consecutively for either 2 clocks or 5 clocks. Let's first look at the formal definition. Minimum of m consecutive clocks, which is 2 here, and maximum of n consecutive clocks, which is 5 here. M can be greater than or equal to 0. And just like in the clock delay range operator, n can be greater than or equal to 0 or infinite. Note that this m cannot be infinite. But here, since this is a range operator, we have a lower limit. So then the upper limit can be infinite. That's the reason for here n can be infinite. Now this seems very benign and very easy to understand. But soon I will show you. Right now actually, let me make a point here. A pound 1 B star 2 colon 5 is equivalent to A pound 1 B next clock B, or A, then B, and the third B. and fourth B and fifth B. Note that this is an OR. So if this condition is met, 2 consecutive B, then the property will end because it's an OR. Either it should remain asserted high, for example, B should remain high for 2 consecutive clocks, or 3, or 4, or 5 consecutive clocks. So obviously, since this is an OR, as soon as we see B followed by B, then the property ends. The overall repetition sequence matches at the first match of the sequence that meets the required condition. Okay, so let's look at this log. Z is high, overlapping operator, A is high, and B remains high for 2 consecutive clocks. So we have met this particular condition and the property passes. It's over. It doesn't need to wait for 3 or 4 or 5 consecutive repetition. In this example, Z is high, overlapping A is high, B is high, the next clock here, A pound 1B, but it does not remain consecutively high for even 2 clocks, and so the property fails. Now let me ask you this question. If the property passes as soon as it sees 2 consecutive, and if the property fails if it does not see 2 consecutive, when will this property ever wait for 3 or 4 or 5 B's? Think about that for a moment. We have 2:5. Why or when would this property ever wait for 3 B's or 4 B's or 5 B's? Will it? Answer is no. It will never wait for this. Then why do we have :5? What good does it do? Why can't we just have *2? I will explain to you why. It is the same property, but here what I'm saying is A, 1 clock later should be followed by B. B should remain consecutively high for 2 clocks or maximum 5 clocks. But after this, 1 clock later, C should be high. Now think of 1 as the ending event, or what I call qualifying event. And you will soon see the significance of C on 5. In the previous slide, as I told you, 5 does not have much meaning because it does not have anything after that. And you will soon see why 5 has meaning, because that is what I call an ending event or a qualifying event. Again, this is equivalent. There should be a C here. So this particular A followed by B followed by C is equivalent to A, B, B, C, or what that means is if this condition is not met, then the property is going to look for 3 B's and then C. If that is not met, then it's going to wait for 4 and so on and so forth. And you will, let me explain this with a simulation log. Here's a simulation log of this particular property that I simulated. Okay, let's start with the very first part of the log. Z is high at time 30. A is high at time 30 as required by the overlapping operator. And B remains high for 2 consecutive clocks. And 1 clock later, as required, C is high. So everything meets and the property passes. This is straightforward. Now let's look at the next part. This is the interesting part. Z is high, A is high, next clock B is high, and then next clock B is high. So 2 consecutive repetition of B as required by these 2. But now what the property does is the next clock, because B has been high for 2 clocks, which meets the requirement, it looks for C to be high the next clock. And you may say that, hey, it's been high for 2 clocks. Next clock C needs to be high. It's not high. Why didn't the property fail? Because look at this again. It says that if this condition is met or this condition is met, that is, this particular qualifying event makes the property now look for 3B, because there is a good chance that if C didn't come after 2Bs, that it can come after 3Bs. So why would we say that the property fails here? That's the reason the property does not fail. It looks for 3Bs, again looks for C, it's not true, so it looks for 4Bs, again C is not true, so it looks for 5Bs, and then looks for C equal to true. 5 is the maximum consecutive repetition requirement. C is true, and the property passes. I will also in just a minute tell you how to read such a property. Now in this case, now this is also very important case, very easy to miss. Z is high, A is high, B is high for 2 consecutive operations. But note, in this case, after second B, C did not arrive, but B did arrive. So the property continued from 2 to 3 to 4 to 5. Here what's happening is, after 2, neither C arrives nor B arrives, and property fails. Well, the bug was that C arrived 1 clock earlier. So don't get daunted by this description. Don't think that this is complicated. Very soon you will understand what that means. Now let me just repeat this particular statement. A followed by B. B should remain true for minimum of 2 clocks, maximum of 5 clocks. B should remain true until C arrives. If you read the statement that way, then it'll make it a lot more sense, and I'll show you a few applications. B should remain true in this range until C arrives. B remains true here for 5 maximum range and C arrives, so everything is okay. B remains true here. B should remain true until C arrives. Well, guess what? B does not remain true here. And okay, if that is the case, if C had arrived here, then the property would pass, just like as I showed you in the very first part of the log. But here neither the B remains true nor there is a C, and the property fails. So again, B should remain true until C arrives. This is how this works. And this is the reason 5, like in this case 5 Bs, are important and are used, as opposed to this slide where this 5 consecutive repetition for 5 will never be exercised. In this case, you definitely see that the 5 is utilized as in this part of the log. Okay, let's look at some applications. So the spec says that if tag error is, we saw this example before in the clock delay range operator. So the spec is the same. If tag error is detected 1 clock later, T error bit should be asserted, meaning is high, and remain asserted, no glitch. It should remain asserted until M check is asserted. This is the until part. This is the qualifying event part. This is how you would write this assertion. Again, as I have said before, and I may repeat this, first derive what is your antecedent. What is it that starts the entire operation of the assertion? If tag error is detected. Until this is detected, nothing matters. So that's why your antecedent is $rows tag error. 1 clock later, or you could have used a non-overlapping operator, but as I was telling you, I prefer to use overlapping and then explicitly wait for 1 clock. It makes it very clear that there is a 1 clock delay. What we are saying is, after 1 clock, T error bit must be asserted, $rows T error bit, and starting that clock, pound, pound, 0. Starting the clock when you see $rose T error bit asserted, that T error bit should remain asserted for 1 clock or forever. And T error bit should remain asserted forever until mcheck is detected. So the consecutive repetition range operator is one of the most powerful operator you will use, and it makes it very easy to wait for a certain signal, high or low, until something else occurs. Because that is infinite, it doesn't mean that it will wait to see that the T error bit is asserted forever till the end of simulation. It does not, because as soon as Rose mcheck arrives, it says I'm done, and what it makes sure that until Rose mcheck arrived, the T error bit remained asserted. As you see in this timing diagram, tag error bit arrives. 1 clock later, Rose T error bit arrives. And then starting same clock, because I have a pound, pound, 0. This is my way of combining two temporal domain conditions. And like I said, well, in this case, if you are going to use and, you better put parentheses properly. Otherwise you may get wrong interpretation. So starting the same time, you now wait for a consecutive high on T error bit until mcheck arrives. As soon as mcheck arrives, the property doesn't care if T error bit goes low or remains high. So this is how you read a consecutive range operator. It is this event that follows the consecutive range operator that makes, in my opinion, the consecutive range operator very meaningful. Let's look at one more application. This is from PCI World. PCI is a parallel bus, as I said earlier, compared to PCI Express, which is a serial bus. In my days, PCI was the popular bus, so my examples are geared towards the parallel bus. Here the spec says that PCI spatial cycle is, PCI has many different cycles: read, write, IO read, IO write, config read, config write. It also has a cycle called spatial cycle. During the spatial cycle, the device select should not be asserted, meaning it should not go active load during the spatial cycle. And this is the spec. Now we are supposed to design an assertion. Here's the assertion. Again, now the PCI spatial cycle, if you're not familiar with PCI, is defined by falling frame and command equal to 0001. Command is also part of the parallel bus. So this $fell frame and command equal to 1 forms a spatial cycle, and again antecedent should be meaningful. Until the PCI spatial cycle starts, nothing matters. So this becomes my antecedent. So what I'm saying is, after the spatial cycle starts, starting the same clock, device select should remain high. That means it remains deasserted. And that's what we are saying here, should not be asserted, meaning remain deasserted. It should not go active low. So we are checking to see that device select remains high consecutively forever until $frame is asserted. The end of PCI cycle is defined by $rose frame. So you can clearly see, again, the quote-unquote and event or qualifying event makes the device select consecutive range operator with an infinite meaningful. We do not know when the cycle is going to end, but whenever it ends, until then, device select should remain high. Now, this is a very powerful language, and that's the part I'm trying to point out here. This is an edge sensitive, it's an edge sensitive event, while this is simply a Boolean, a level sensitive event. But guess what? You can do a logical AND of both the edge sensitive and level sensitive event. This makes it very powerful in many different kind of applications. One more application. Make sure, now this is a very good application that you probably will be able to apply directly to your project. Make sure that the state machine does not get stuck in current state except idle. If the state machine is in idle, it can stay in idle forever. But in any other state, it does not get stuck. Now, what is stuck? Stuck can be, let's say, the state doesn't change for 32 clocks or 64 clocks or whatever your design is specifying. So how do you write an assertion for this? Using the consecutive repetition operator. Again, here antecedent is that if the state is idle, everything is okay. If the state is not idle, then the state machine should not get stuck. So here's the antecedent, which is pretty much the whole spec. That's okay. If the current state is not idle and $stable, that means the current state remains stable, remains whatever it is for 32 clocks consecutively. This whole, see the parentheses. The parentheses are outside of this entire logical AND. That means for consecutively 32 clocks, make sure that the state is not idle. For example, if the state goes to idle, then we don't care and the antecedent will restart all over again. So if the state is not idle and we stay stable in whatever the current state is for 32 clocks, then we know that you're stuck in the current state. And this is a very powerful feature again. What we are saying is if the antecedent matches, then this property fails because the antecedent says that, yep, you are stuck in a current state for 32 clocks. So what does that mean? It implies that there's a failure. So, So basically, a hard failure can be applied as a consequent. This is another powerful feature because sometimes you don't have any condition in the consequent. You simply want to say, hey, if I see this as an antecedent, if I see this, whatever it is, I just want to declare a failure. So that's another powerful feature. And this is how this particular spec is very much common in most of the RTL. You do not want to get stuck in a given state. So here's your assertion to do the same thing. Okay, folks, this is all about the consecutive repetition operator. I'm keeping the lectures hopefully small enough for each operator. Thank you for attending the lecture, and I will soon see you in the next lecture.